Okay. So we're just going to run through a couple of things. And again, when we do these problems, you want to consider these as part of the assignment. Here's our objective. If you haven't written the word right there, that's really the hardest part for most people when we're doing these. I can write and solve quadratic equations in context. Coming up with the equation can be kind of tough. And we're going to spend about 3 days going over all different types of quadratic equations and writing them down from the context of a real world situation. So would you write the word real there? Because that's where these become useful, was when we can solve a real world problem and use the quadratic model to figure out the answer to a problem that we're curious about. So remember, we've got a quadratic, which the shape of that is a parabola. So we just reviewed those shapes. Now, when we're solving these, there are lots of different features. When we analyze a quadratic and we look at the graphs, we might be interested in what are the zeros? In other words, what are the x-intercepts, the solutions, the roots or whatever, the max or min. We might be interested in where the max or min occurs. So that would be a question about the x-coordinate or the horizontal coordinate. Okay, so where the max or min occurs. And we might just need to evaluate the function somewhere once we've figured out what it is. And a couple of hints for writing these down. Identify what you know, so read the problem carefully and figure out what you know. Determine what you're trying to find. Draw a picture or a diagram. That'll help you visualize what's going on, and this is especially true if we've got a geometry problem or something. Label all the parts of your drawing if you can. So that would be axes, pieces of the geometric shape, the square, the rectangle, whatever it happens to be. Use familiar formulas, again, from geometry, area of a rectangle, area of a triangle, perimeter, different things like that. Check your answer for reasonableness and accuracy. Does your answer make sense in the context of the problem? If it doesn't, you probably ought to throw it out or maybe try something else. Make sure you answer the entire question. There may be more than one question that you're interested in. And use appropriate units. I used to think units weren't that big a deal, but units can actually help you figure out, okay, did I do this right? Are things canceling the way they're supposed to be? And then before we start this, these are just classic algebra problems that we're going to start off with. We want to make sure that we know what the word consecutive means. So can somebody raise their hand and tell us what the word consecutive means? Got a big hint right here. Luke?
In a row.
In a row. Okay? So if the first integer is 2, what are the next 3 consecutive integers? So if we've got 2, the next consecutive ones would be 3, 4, and 5. Thanks. If the first one is x, what are the next 3 integers? That's a little tougher question. Can somebody raise their hand and tell us, if the first one is x, how could you express the next one? Yeah. We could, but that introduces another variable, and that thing makes things complicated. Zach?
X plus 1.
Very good. X plus 1 would be the next one. X plus 2 would be the one after that, and x plus 3 would be the one after that. So if they're consecutive integers, we just add 1 to get from one to the next one to the next one to the next one. Okay? Now, key word right here is if they're odd and the first one is 7, and again, I get to answer this one. Okay, the next 3 consecutive odd integers would be 9, 11, and 13. So if the first odd integer is an x, don't say anything out loud. Think about it for a second. Colson, do you know what the next one would be? Very good. And the one after that, crew?
X plus 4.
X plus 4, and the one after that would be x plus 6. Because there are 2, there's an even in between every odd, so we have to jump the even, so we're going to skip by 2's. So if we take a look at the next one, if they're even integers and the first one is x, how would you express the next one?
It's x plus 2, x plus 4, x plus 6.
X plus 3, right?
It's exactly the same.
What the fuck?
Wait, then why? Because so say x was like 2. When you add 3, you get an odd number. Yeah. So you have to add 2 and 4 and 6. You can't add 3.
Then explain the last one.
It's the same thing, but odd. So say x was 1, if you add 2, it's 3.
Oh.
If you add 1, it's even.
Oh, yeah. Jack, you stupid. Okay, I get it now. I get it.
We got it?
Listen, that's crazy.
I'm the new teacher.
Yeah. Okay.
I get it. I get it.
Very good.
We're so proud of you.
All right.
Oh
So
my, that was.
let's
Wait,
use
wait.
those.
Wait, go back really quick. Like on number 2, where it's like.
Oh, this guy right here. No. Oh, this one?
Yeah.
No, I had that right. That's a 3.
Yeah, but shouldn't it imply that x plus 1?
Because it's consecutive. It's not odd or even.
But x already has like a 1.
Exactly. So you're adding 1 to it.
So let's say the first one was a 2. You add 1, then you add 2, then you add 3 to get from 1 to the next to the next to the next.
You have to add 1 to get.
But you're not adding like on, just adding substitute.
Okay, we could write this one as x plus 1 plus 1 and x plus 1 plus 1 plus 1. How about that?
Yeah.
Okay. Good?
Yes.
Let's just keep going.
Like, wait, like.
We're gonna let Crew stew on that for a little while. Let's take a look at this one. Okay. You want to have time to work in class, believe me. Okay, find 2 consecutive odd integers whose product is 399. Use your calculator to get some help. So, watch. 2 consecutive odds. So the first one is going to be x. The next one is going to be x plus 2. And we want their product to be 399. So we want to multiply the 2 of these together and get 399. Okay, that's the right part. And I need you to stop talking and pay attention. Okay. Writing it down is the hard part. After that, then we can solve it using a bunch of different techniques that we've got. What we usually do when we're solving a quadratic is we set it equal to 0. So the first thing I'm going to do is I'm going to multiply through. So this gives us an x squared plus 2x minus 399 equals 0. So we can take advantage of the 0 property of multiplication. And then these are big numbers on some of these problems. So what I would probably do is I'm going to shrink this down. And I'm going to grab the calculator, and remember that nice little trick where we take this, and I'm going to clear both of these off. I'm going to take the number that I need. I don't care whether it's positive or negative. I'm just going to put it in as 399. I'm going to divide by x, and then I'm going to go to the table. So hit second graph. That's going to be, whoops. Second in graph. There we go. I'm looking for 2 numbers that are how much apart? Just 2. Hang on. Okay. There they are right there. 19 and 21. Okay. If they're going to multiply to be negative 399, one of them needs to be negative and one needs to be positive. Since the middle one's positive, we're going to factor this to x plus 21 and x minus 19. So the answer that comes from this factor is negative 21. And the answer that comes from this factor is 19. Those are not the answers to the problem. Those are answers for x. And remember what x is. X is the first one. So if the first one is negative 21, then the next consecutive odd integer is negative 19. And you would get that by adding 2 to it if you wanted to use the formula up here. So there's one pair that would multiply to be their consecutive odd integers, and they have a product of 399, positive 399. And if the first one was 19, again, add 2. The other option would be 19 and 21. Okay. Questions? Mason.
Where'd you derive the x times x plus 2 equals 399 from? Oh,
Because
is that
it's-
because the x plus 2 is the second? Okay, I get it.
Mm-hmm. Okay, any other questions?
No.
Okay, let's take a look at the next one. The next one is a little different.
Yeah.
it says find 3 consecutive integers, not odd, but 3 consecutive integers, such that the product of the first two plus the square of the third is equal to 137. So the first thing is they're 3 consecutive. There's no odd or even in here. So that means the first one is going to be x. The second one is x plus 1. And the third one is x plus 2.
You do x plus 1 plus x plus 2, right?
Hang on. Okay, that's how we're going to represent the 3 numbers we're looking for, because it said find 3 numbers. That's the question. That's what they're asking for. Such that the product of the first two, so if you multiply the first two together, so if you take the first one and the second one and multiply them together, plus the square of the third one, x plus 2 quantity squared, is equal to 137. And now we're going to multiply. So this is the right part. If you can get to here, you can probably solve it. So this is x squared plus x. This one, if you're good at squaring those binomials, this one is x squared plus 4x plus 4, and that has to equal 137. There's no 137 property of multiplication, so we want to get a 0 on that side. So I'm going to combine the two of those, and I get 2x squared. I'm going to combine the two of those, and I get 5x. And then when I move this to the other side by subtracting, I end up with negative 133.
That would be correct.
Okay. Do you want to use factoring, or is there another method that you want to use?
Can we just
Yeah.
do quadratic formula?
We could use the quadratic formula. Okay, we're going to use our calculator for this, so everybody watch. We're going to get x equals, this would be a negative 5, plus or minus, we're going to do b squared, so that's going to be 25, minus 4 times a times c, so that's going to be a 2 and a negative 133. All over 2 times 2, so that's going to be over a 4. And like I said before, I usually just write 25. I'm going to be adding something. I'm going to be adding 8 times 133. Now we're hoping that this all works out nicely. So let's see, 25 plus 8 times 133. I get 1,089. And I'm really hoping that has a nice square root.
It does.
33, that's good. So negative 5 plus or minus 33 over 4. So negative 5 plus 33 over 4 and negative 5 minus 33 over 4. So that's going to be 28 over 4. So that's a 7. And the other one is, let's see, that's a negative 38 over 4. And that's going to work out to be 9.5, right? Negative 9.5?
Yeah, sure.
Is that the answer?
No.
Why not?
Because it's what x equals.
It's asking for
Oh
three
yeah, that's right.
consecutive
That's
numbers.
x.
Luke?
It's asking for 3 consecutive numbers.
3 consecutive
Integers.
integers, not an integer. So you can throw that one out. So that means there's only one answer. The first one has to be 7. The next one is 8. And the last one's 9. Okay?
That took way too long.
7,
8, 9.
Oh, don't be a baby.
46, 47.
Oh my God.
Wait,
Luke.
You just do exactly what you did earlier and pop it into the calculator.
What do you mean pop it into the calculator?
So go back to
Factor
x
it?
Okay, we'll see.
times x plus 1 plus x plus 2 squared.
Mhm.
And pop that
Why?
into the graph.
Because
And,
because
And
9/11.
let's see.
hey fellas, stop talking and listen.
Find y equals 137, and then you get one number and find the others from the first number.
Yeah, you could do that, but you're going to have to show algebraic work. We're not using graphing on this.
Could
Okay.
you just like guess and check? That's
Sure,
what I did,
you
and,
could-
and it worked.
Wow. Okay, flip the page over.
So just
What? It doesn't equal
did you
137.
just multiply them? Well,
It's
yeah.
the square of
Yeah.
the third one, right?
The square of the third one. Multiply these two together.
So
7 times 8 plus 81.
Okay.
Or I'll do 9 squared. Okay, flip the
wait,
page over.
56 plus 81.
Okay, give it a shot. Go.
Wait.
It'd be like this.
Okay, that's long enough. If you missed a word, you're going to do this the wrong way. Look at the other two problems that we just did. There's a word missing from this. Consecutive. These are just two integers. Find two integers whose sum is 9, so any two. So I'm going to say the first one is x and the second one is y. And it says their sum is 9. So that means when you add them together, you get 9. And it says their product, so if you multiply them together, you get negative 52.
You just do it.
No, do it this way. Hang on. So I'm going to solve this for one of them. I'm going to solve for y. I'm going to take this one and I'm going to write y equals 9 minus x. So wherever there's a y in the other problem, I'm going to plug in a 9 minus x. So this is x times 9 minus x equals negative 52. And now we've got a quadratic that we can solve.
Oh, okay.
Their sum is 9. That's the first part of the problem. Their product is negative 52. So I take this one, solve for y, and then I'm going to replace the y with a 9 minus x. So this is a 9x minus x squared equals negative 52. I'm going to move them to the side where they will have a positive x squared. So this is going to be 0 equals x squared minus 9x minus 52. So I'm looking for two numbers that multiply to be negative 52 that combine to be negative 9. So if we just stop and think about numbers that multiply to be 52, there's not very many of them. So we could use 1 and 52, doesn't have a difference of 9. 2 and 26, doesn't have a difference of 9. 3 and
14.
17,
Wow.
17 and the third repeating.
3 and 14.
What?
Is that right? 4 and 4 and 13. There it is. So this is going to factor to x minus 4. Whoops. Yeah, x minus. Nope.
3 times 14 is 42.
Oh, let's see. No.
Right.
Oh, does 3 go in there? No, 3 doesn't go in there.
It's
Yep.
4 and 13.
Yep, 4 and 13. So this is going to be x plus 4 and x minus 13. Oh, it's just on my, in that envelope there. Over by my water bottle. There you are. Thanks. So this is going to be negative 4, and this one's going to be 13. And it just says find two integers whose sum is positive 9. So let's take a look at this. If the first one is negative 4, I plug this in right here. This would be 9 minus 4. So that would be
It's a plus.
13.
Oh, yes.
If the first one is 13, this would be 9 minus 13. So the other one would be
Minus
negative 4. So take a look. Same answer either way?
I would believe
Okay.
so. Why'd I get the flip?
What's that?
Why'd I get the opposite?
Did you factor it wrong? Did you write the wrong one, make the wrong one negative?
No. Okay, wait, where did the negative on the x squared go over there?
We moved those over to this side.
Yeah. Oh, yeah, my bad.
So you only get one set of answers. It's this one or this one. They're the same. Okay. All right, slide down. Next one. Notice that we're just talking about numbers here. Over and over again, we're talking about numbers. Find two numbers whose difference is 8 that have a minimum product.
What does that mean?
Let's think about it. Find two numbers. Doesn't matter what the numbers are. Does it say integers?
No.
Nope. Okay. And the difference has to be 8. So the first one is going to be x. The second one's going to be y. And we're going to find the difference between the two of those. And the difference has to be positive 8. And they have a minimum product. So their product is x times y, and we want the min out of that. Okay. Earlier today, I was teaching a secondary 1 class, teaching them how to solve systems of equations. You can't solve equations with two variables. So we take this and we change this so that there's one variable. So take a look here. I'm probably going to move the y to the other side. Because if I move the y to the other side, then I have positive. So that means x is equal to 8 plus y. So wherever there's an x, I'm going to put a y. So I'm going to replace this with 8 plus y times y. D. Hang on. Okay. This is our function. Okay, now, we can do this without a calculator. What shape is this if we multiplied these together? It's a parabola. Starts off with a y squared plus 8y. Okay, now, don't let the y's mess you up and let you think, okay, we're switching variables or something like that. This is still shaped like a parabola. It's a parabola that opens up, right? Okay, these are the intercepts. These are the solutions. These are the roots. So one is at negative 8, and the other one is at 0. So it crosses at 0 and crosses at negative 8, and it opens up. Where would the vertex be?
In between negative 8 and 0.
So the coordinates would be negative 4 comma, and then how would you figure out what the coordinate is? What the other coordinate is?
Plug it in.
You'd plug it in, okay?
So x is negative 2. Right? Yeah.
So we figured out what? Hold on just a second. Okay, so this does get a little bit confusing. We just figured out what the y coordinate was. Sorry, let me put it this way. Oh, this is interesting. Okay, we figured out what this coordinate right here is, which is the answer to this one. Okay, so this is a negative 4. Does everybody agree with that?
Yeah.
Okay, that's what the y is here. So x is going to be 8 plus negative 4. So that's going to be 8 minus 4. So we end up with 4. So one of them is 4. The other one is negative 4. Are those 8 apart? It is. Okay. So this one is our x and this one is our y. So the first one is 4. And the second one is negative 4. And if you multiply those together, the minimum product is negative 16.
Wait, why's the y?
So if I understand what this graph is representing, the x's and y's on all of these, those pairs all subtract to be 8. So,
Every one of them?
Yeah.
No.
No.
No. No. Let me do one more and then we'll start working on some problems.
Why is the y equal to 0?
Okay. So take a look over here.
Because
This
you
hold
said
on,
y
hold on.
equals 0.
Let me answer the question and then you can try. Okay, this is factored, right? What's the solution that comes from this one? Negative 8. What's the solution that comes from this one? 0. Okay. This is a parabola, right? And it opens up. So we've got this shape right here. It crosses at 0 and negative 8. So the vertex would have to occur at negative 4. So that's going to be our coordinate for this one. Okay. So that's going to be a -4. And then once I know that one, I can plug in here and figure out the other one. Okay. Oh, these take a while to sink in. Okay, last one. What is the maximum product of two numbers whose sum is 16? So they have to add up to be 16. So I'm going to take the two of them and add them together and get 16.
Okay, wait, you should let us do this one.
And we're going to multiply them together, and we want to have the max product. I'm going to solve for the y again, so I'm going to subtract 16. So this is going to be x times 16 minus x. And this will be a little more comfortable because this is like an f of x. What shape is it? Parabola. Which way does it open?
Oh, yeah.
Careful, take a look. 16x minus x squared. The x squared term is negative, so it's going to open down. So will it have a max?
Yeah.
It will. Okay. Would you figure out what the answer is to this problem? You're looking for two numbers, and you want to know what their max product is. How we doing, DNJ?
Tired.
Oh.
What? Oh, okay, I got it.
Okay.
No.
Worse than it looks like you got your thinking cap on. Yeah,
Oh, that's why.
because the hat.
I think I got that. That's why I got it wrong. X minus.
Has a root at 0 and a root at 16, right?
Yeah.
And it opens down. So if this is 16 and this is 0, what's that coordinate of the vertex?
8.
8. Okay, 8 is the variable we're looking for. So that means x is 8. So if x is 8, I can plug it in right here. I get y equals 16 minus 8.
Oh, I did.
So that means what's y? 8 also. So the two numbers are 8 and 8. And they didn't ask for this on this particular. Oh, what is the maximum product? They did ask for the max. The max is 64. Okay.
7 and 9 is pretty close.
Okay. Let me just show these really quickly and take a look here. I want to point something out. Okay, hold on. Let me finish. Then we'll talk about other options. Okay, notice that on this one, it's more comfortable for our brains on this last one because we kept everything in terms of x. That's how we normally do things. If you want to do that every time, if this scrambled your brain right here on part D, where we moved this over and wrote a function in terms of y, it's still the same type of shape. We have a y-axis and an f of y-axis. We could have done a's or b's or q's or whatever happens to be. If you want to always write it in terms of x so that makes that more comfortable, that's totally okay. You would just move the x over, then multiply everything by a negative, and then you'd plug in for y, keeping everything in terms of x. Okay? All right. I'm going to hand out the assignment. I'm going to stop this first, though.